Hello, this is Unit 2, Day 10 notes. So this is the second part of Unit 2, and we're going to look at the trigonometric identities today. The Pythagorean identities come from the Pythagorean theorem, which is a squared plus b squared equals c squared. You know that in a unit circle, our hypotenuse is always going to be 1. So that's my c is going to be 1. My x values are cosine and my y values are sine. So this is how we got cosine squared plus sine squared equals 1. If we divide everything by sine, everything is divided by sine, we're going to get cosine squared over sine squared, which is cotangent. Sine divided by sine is 1. 1 divided by sine squared is cosecant squared. If we had divide everything by cosine instead, then we're going to get 1 plus tangent squared equals secant squared. And we can manipulate this function or this equation to get other identities to plug in. We have our quotient identities. We know that tangent is sine over cosine. Cotangent is cosine over sine, the reciprocal. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is also 1 over tangent, right? So cotangent is cosine over sine or 1 over tangent. We know these. We're going to verify trigonometric identities, and these are going to be the steps. I will always, my advice to you is to always try to start with the more complicated side. And then we're going to try to put everything in terms of sine and cosine first. So let's try example 1, and then I'll read the rest of the directions. I'm going to start with the most complicated side. It's more complicated to start with them apart, and then we'll see how we can get them to go together. These are multiplied together. So I'm going to start with the left-hand side. And tangent and cotangent, I'm going to express everything in sines and cosines. Tangent is sine over cosine. Cotangent is cosine over sine. We're not going to manipulate the right-hand side. We're only going to work with one side. We never touch the other side. You're not changing the other side. The other side is my goal to get the left-hand side to look like the right-hand side. Okay, so I'm always going to try to combine, if we have rational expressions, we're just going to combine these fractions. We need to have a common denominator if we're going to combine fractions. So the left fraction, sine over cosine, I'm going to have to multiply by sine over sine. Sorry guys, so you're going to multiply this side by sine over sine so that we can have the common denominator. Whatever I do to the top, I have to do to the bottom to make it just 1. Now this side, I'm going to have to multiply by this denominator, which is cosine over cosine. All right, now I can just multiply straight across. Sine times sine is sine squared. Cosine times cosine is cosine squared. Now we have a common denominator, sine times cosine. So it's all divided by sine times cosine. And remember that my goal is to make it equal to the right-hand side. And we usually use RHS for right-hand side or LHS for left-hand side, right-hand side. Okay, so we know because of our Pythagorean identity that cosine squared plus sine squared equals 1. So sine squared plus cosine squared is 1 over sine squared cosine squared. So I can separate these to be 1 over sine times 1 over cosine. If I multiplied these together, it'd be 1 over sine times cosine, right? That's what we would have. So I'm just separating them so that you can see how I'm getting the right-hand side. Which one is first? So they want us to have secant first. Okay, so I'm going to write this one first. 1 over cosine is secant. and then 1 over sine is cosecant. And then, so we have proved it, we're done, and then we can write QED. Okay. That means we're done. Alrighty. Example 2, let's try this one together. So this one is secant squared minus 1 over secant squared x equals sine squared x. We can all agree that the left-hand side is more complicated, okay? I'm not going to put all of these into cosines, really. I don't need to put anything in sines. What I'm going to do is I'm going to recognize that this is the Pythagorean identity, just dividing by cosine, everything by cosine. So I know that secant squared minus 1, I can use this identity to plug something in. So I'm going to write down the identity. I'm going to write it down right here. 1 plus tangent squared theta equals secant squared theta. But I want it to look like this, secant squared minus 1. So what I'd have to do is subtract the 1, and then I'm going to get tangent is equal to, tangent squared is equal to secant squared theta minus 1. So this is secant squared theta minus 1 is equal to tangent squared theta. And I'm going to use x's because this equation uses x's. All right, so this is tangent squared theta divided by, and then on the bottom we still have secant squared x. So I'm sorry, I told you I was going to use x's. I don't know. So tangent squared x over secant squared x. We're trying to make it look like the right-hand side, sine squared x. Okay. Now I am going to express it into sines and cosines. Tangent is sine over cosine. And then we're dividing by secant. Sorry, these are all squared. And we're trying to make it look like the right-hand side. We do not divide when we have fractions. We multiply by the reciprocal. So secant is 1 over cosine. So I'm going to make this a fraction. Secant is 1 over cosine. So when I multiply by the reciprocal of it, I'm still going to have sine. Remember, you cannot flip the first fraction. You can only flip the second one. It's going to be cosine over 1. Do you guys see that the cosines will cancel? Sine squared x times cosine squared x divided by cosine squared x, these will cancel. This is now 1. Cosine divided by cosine is 1. And we're left with sine squared x equals the right-hand side, which is also sine squared x. We're not changing the right-hand side. We need the left-hand side to be equal to the right-hand side. So we're done. And then we can say QED. I think that's it on this page. Go ahead and flip your papers over. All right, can we use a strategy to prove that maybe this side is equal to the right-hand side? So this one, it says that this strategy is use a conjugate. Remember we learned complex conjugate with the i's. So conjugate, I'm going to start with the left-hand side because it's easier to go from a fraction to a non-fraction. So I have cosine of x over 1 minus sine of x. A conjugate means we're going to multiply it by 1 plus sine of x. Remember, whatever we do to the bottom, we've got to do to the top. We can't just multiply by 1 over 1 over 1 plus sine of x on each side. So, because we're not multiplying anything on the right hand side. So I've got to multiply the top and the bottom by the same thing. And this one, I am actually not going to simplify yet. I'm going to show you why. So I have cosine times 1 plus sine of x divided by, I am going to simplify the bottom. I'm going to FOIL it. This is a binomial times a binomial. So my first two terms are 1. My outer two terms are 1 times sine of x, positive sine of x. My inner two terms are negative sine of x. This is why we do the conjugate, so that they will cancel each other out. We will never have a middle term, which is nice. And then my last two terms are negative sine of x times sine of x, which is sine squared x. And we're still trying to make it look like the right-hand side. All right, so this side, or the numerator, is still going to be cosine of x times 1 plus sine of x. The denominator, I can simplify these. Sine of x minus sine of x is 0, so we have 1 minus sine squared x. And I know from the Pythagorean identity that sine squared x plus cosine squared x equals 1. I want it to look like this. 1 minus sine squared of x. In order to do that, I need to subtract sine squared of x. What I'm left with is cosine squared of x equals 1 minus sine squared of x. Okay? And that's what I'm going to plug into here. So 1 minus sine squared of x is cosine of x. So I'm going to say, well, this is cosine squared. The denominator is cosine squared. The numerator is going to stay the same for the moment. Now I can cancel these two. That's why I didn't want to distribute it, because I knew this was going to be able to be canceled. So 1 divided by, or cosine divided by cosine is 1. What I'm left with is 1 plus sine of x over cosine of x. And what's really nice is we can always separate the numerator, not the denominator, but we can separate the numerator. So this is the same as 1 over cosine plus, and then sine over cosine. Now, 1 over cosine is secant. Sine over cosine is tangent. Is that equal to the right-hand side? It sure is. Secant x plus tangent of x. We got it. All right, let's try another one, and then you guys can try one. This one, it says 1 divided by 1 minus sine of theta plus 1 over 1 plus sine of theta equals 2 secant squared of theta. First, let's rationalize, or let's combine these rational expressions. Let's combine these two. But in order to do that, they have to have a common denominator. So we've got to multiply this one by 1 plus sine of theta and this one by 1 minus sine of theta. We've got to multiply them by their opposites, denominators. So I'm going to just rewrite this. This is 1 over 1 minus sine of theta. And I'm going to multiply it by 1 plus sine of theta over 1 plus sine of theta. Plus, this one is 1 over 1 plus sine of theta already. And I have to multiply it by the other denominator, which is 1 minus sine of theta over 1 minus sine of theta. And hopefully we can get it to look like the right-hand side. Okay, now I'm multiplying the numerator and the denominator. So my numerator is going to be 1 plus sine of theta plus, this one is going to be 1 minus sine of theta all over this denominator, which is 1 plus sine of theta, 1 minus sine of theta. They're the same denominator. I can FOIL this denominator, which is going to be 1. Remember that we're multiplying them by the conjugate. So it's going to be sine of theta minus sine of theta. That will cancel. And then we will have minus sine squared theta. And hopefully we will get this to look like the right-hand side. 1 plus 1 is 2. Sine of theta minus sine of theta is 0. So I have 2 over 1 minus sine squared theta. And I have this identity. Almost always whenever we see a sine squared or a cosine squared or something squared, we're going to use the Pythagorean identity. So the one that I'm going to use is this one. I want it to look like 1 minus sine squared theta. We know that this is equal to cosine squared. So I'm going to use my identity. It's called the Pythagorean identity to get 2 over this is going to be cosine squared of theta. Anything over cosine is going to be secant. So this is 2 times secant squared theta, which is equal to the right-hand side now, which is 2 secant squared theta. QED. We're done. That one wasn't too bad. I want you guys to try the next one. And then you guys have a couple of classwork to try out. If you have any questions, please ask me.